Professor Belfrost's science class is back.
Okay, welcome back to my class. As what I have promised before, that today's video will be about the review on our first chapter on physics. Congratulations, we have done with the first chapter on physics, which is kinematics. Now, let us review a little. Okay, let's see if you still understand me that I want to see how you have learned so far. If you have any problem, please feel free to tell me about that. Okay. So here's the first review problem. So what are the magnitude and sign of displacement for the motion that is shown in a figure A and B? Okay. So maybe you need to zoom the picture. Okay. But actually, it's not very difficult to find displacement. I need plug all the known values to the equation delta x equals xf minus x0. I'm sorry, I mistyped it again. Okay, that is not xf equals x0. Okay, xf minus x0. I always mistype something when I am in okay. So we have identified that for part A, the xf is 6.7, x0 is 4.7, x and for part B, its xf is 3.75 and x0 is 5.25. Once again, all is in three significant figures, though I only read in two significant figures if the last digit on the number is 0. Okay? It's very important actually, but I'm just uh, being lazy to write it for you. Okay, so by solving it, then it yields for the part A it is plus 2.00 kilometers, and for part B it is minus 1.50 kilometers. And it means that for part A that the motion is to right, and for part B the motion is to left. Okay. Number two, what are the distance the travel for the motion shown in part A and part B of the subway train previous? Okay, so you need to distinguish these two first. Okay, so distance between two positions is the magnitude of displacement. We have found this before, but distance traveled is different again. It is the total length of the path traveled between the two positions. Okay, in the case of subway train zone, then the distance traveled is the same as the distance between the initial and the final position of the train. So actually the displacement for part A is plus 2, then the distance uh, between the initial and final position is 2 kilometers, and also the distance traveled is 2 kilometers. But for part B, because its displacement is minus 1.50 kilometers, then the distance between initial and final position is 1.50 kilometers, and the distance traveled is just 1.50 kilometers. But I want to warn you that distance between initial and final position sometimes will not be the same as distance traveled. Okay, because when we say distance between initial and final position, it actually related with displacement, but distance travel may be greater because we you can just go forth and back, okay, and it will count. But if we just want to consider about the initial and final position, the it will not show us this information. Okay, please be very careful. Number three, suppose the train from A on previous problem accelerates from rest to 30 kilometers per hour in the first 20 seconds of its motion. So what is the average acceleration during that time? So now again we need to make a simple sketch as shown with a proper coordinate system. And this involves three steps. First is to identify the knowns. Second is to calculate the delta phi as shown, while where plus sign means that the velocity is to the right. And three, just plug all the known values and solve the equation for the unknown, the a bar, which is the average acceleration. Okay. So a bar is just delta v divided by delta t, and by doing some uh, conversion on the units, okay, we can obtain the result, which is 0.417 meters per second. Why is represented as 0.417 meters per second square? Again, because we stick to the convention to use three significant figures in this problem. Always take care of these, okay? Always be aware of this. Okay. Number four. Now suppose that at the end of its street of the train trips of this previous problem, then it slows to a stop from a speed of 30 kilometers per hour in just 8 seconds. So what's the average acceleration? Now again we need to sketch. After it, identify the knowns, solve for the change or delta of velocity, which is minus 30 kilometers per hour. Then just to the equation and solve for it and do some unit conversion, and we obtain minus 1.04 meters per second square. And minus sign indicates that this is an acceleration to the left, which is oppositely relative to the direction of the motion. Okay, done with number four. Number five, sketch the graph of position, velocity, and acceleration versus time for the trains from two last problems. Okay, taking the velocity to remain constant from 20 to 40 seconds, after which the train decelerates. Okay, because this is a graph, this is the problem that you need to uh, actually pay your time to understand. So I'll leave it for you. Okay, I'll not explain it. Just take a screenshot of this slide and then read all the description that I've given to you. Understand how I plot this graph for the A, B, C, respectively position versus time, velocity versus time, and acceleration versus time. And if you have any question later, please feel free to contact me. Okay? Done. Number five. Actually, not done. This is your assignment. This is your task. Okay. Number six. Suppose the train below slows to a stop from a velocity of 20 kilometers per hour in 10 seconds. So what is its average acceleration? Okay. By paying attention to the graph of the problem, actually it's already very clear. But let's draw a much more simplified sketch, like shown on the slide. Then, as before, we need to do some steps. The first one is to identify the knowns, then calculate the delta phi, which gives us plus 20 kilometers per hour, and then just solve for the a bar, which is after doing some unit conversion, we obtain plus 0.556 meters per second square. A plus sign again means that the acceleration is right, and this is reasonable because the train initially has a negative velocity to the left and positive acceleration opposed to motion, and it will change the direction to right. Okay. Number seven, suppose a car merges into freeway traffic on a 12-meter long ramp. And if its initial velocity is 10 meters per second and it accelerates at 2 meters per second square, then how long does it take to travel to 12 meters off the ramp? Okay. Okay, from the information given, we can draw a simple sketch as so. And we are asked to solve for the time t. So first, again, we need to identify the knowns and what we need to solve for. Okay, by knowing what is known, this is v0, a, and x, and what we need to solve, this is t, then we can consider which of set of equations which is best, which will work out the best for our problem. And after some consideration, we do some thinking. Okay, then we got it. The answer is the best equation to be used in this problem is x equal x0 plus VOT plus half times AT squared. Okay? Because we have all the known and the unknown That's what we want to find. Okay, so you just need to plug all the knowns and simplify the equation. We have the algebraic equation, do some manipulation, rearranging the equation, and use the quadratic formula, the Alcorn formula. And after doing that, we are done. And it yields two solutions as usual, 10 and minus 20. But because negative value for time is unreasonable in this case, they pick the positive one, which is t equals 10 seconds. Sometimes also you get two value. Okay, one is 0 for example, and one is another value, positive value. Then also the positive value, for most of the time the positive value will be the one that you expected for the result. But sometimes please pay attention to what uh, the question expect us to give. Okay, for example, it asks us for velocity, then the velocity can be plus, can be negative. Actually, they are both acceptable. If if the question indicating that the velocity to be given is positive, then you need to pick the positive result. But if the velocity it is like opposite, or it is a downward velocity, then you'll need to take the negative result. Okay, please pay attention to that. Number 8, a chunk of ice breaks off a glacier and falls 30 meters before it hits the water. Assuming it falls freely, how long does it take to hit the water? Okay, so we have identified the nodes y0, y, and a. Then just plug it into the equation. Okay, which is y equals y0 plus v0 t plus half times at squared. Ranging the equation that we get, it is about 2.5 seconds. Okay, done. Okay, so that's about the review problems. Now here's the exercises for you. I have some exercises for you. Please try to solve it first. If you have any problem in solving the exercises that I've given you, please feel free to tell me in the comment section, or you can just email me, or if you know my Instagram, just visit the Instagram and DM me. Okay, we are done. Actually, this is maybe the shortest video, because actually I want to tell you something that's great. Okay. Okay, so but before the great announcement, here's the quote for you today. Okay, so Anatole France once said, "All changes, even the most long for, have their melancholy. For what we leave behind us is a part of ourselves. We must die to one life before we can enter into another." Okay, actually it means that all changes is painful. Okay, there are no change that doesn't leave any scar. We need to heal. Okay, we need to accept that we will lose something when we change, but the change will bring something more more precious to our life. Okay, so that's why we need to accept the condition, circumstance, and try to move on to be a better, a new life. Okay, a better of us. Okay, better version of us. Okay, so the announcement. Okay, following up with this. Okay, thanks for watching. Subscribe, give a like, comment, and share. The great announcement for you today is that we have launched our website. By the time you watch the video, I'm 100% that the website has been running smoothly. So please visit it on https colon slash slash sciencewithx4st.unaux.com. And my class, as usual, will be back on Tuesday and Thursdays. Oh, so actually, why I want you to visit this website, because I will share uh, much more materials and exercises on this website. Okay, on the section called learning resources. Okay, so they are free. You can access it and learn it by yourself. Because sometimes there are something that I want to tell you in this class, but I forget, or maybe I find it this is a more advanced topic, so I will put it there. Okay, and you may just go to visit this website and just click the link that's given and access the free learning resources just for you. Okay, so that being said, thank you for today, and see you on my next video. Goodbye. Ciao.